And did you want me to wait around for the lobby to fill up a little bit before I do press play, or were you just happy for me to press it as soon as 10 o'clock hits?
Yeah, let me just introduce the speaker. Is that okay?
Yeah, that's fine.
All right. So hello, everyone. So my name is Abimbola Windapo, and I'll be sharing this session, this online session. In this session, we have 3 papers that will be presented under the challenges in data collection sessions. And the first paper will be presented, or is a pre-recorded presentation by Søren Wandahl, using smartwatches to understand the relationship between construction workers, travel distance, and time spent on direct work. So, over to you.
Hello, everyone. I'm going to present the paper with the following title: Using smartwatches to understand the relationship between construction workers' travel distance and time spent on direct work. The authors of this paper are Cristina Peréz, which is me, Stephanie Salling, and Søren Wandahl. We are part of the Department of Civil and Architectural Engineering at Aarhus University in Denmark. The presentation is going to follow the same structure as the paper. Let's start with the introduction. Among the different possibilities of Construction 4.0, one is to use sensors or trackers to measure workers' activities to understand how workers spend their time on construction sites. Several technologies approaches exist to automate data collection on workers, mainly related to 2 kinds of categories: computer vision-based technologies and sensor-based technologies. Sensor-based technologies using body-worn sensors have gained greater attention for monitoring construction activities among researchers. They use inertial measurement units or also location-based sensors, like the famous GNSS, the Global Navigation Satellite System. However, most of those type of approaches require extensive data training and also extended data analysis periods and are challenging to implement by practitioners. This motivated the authors of this paper to select smartwatches for understand outdoors worker positions. The present study presents the following research question: which is the relationship between travel distance and time spent in direct work? The reason for trying to answer this question is because maybe in future studies we can measure time spent on direct work indirectly by measuring travel distance. Let's talk about the work sampling studies that use digital technologies. The work sampling technique consists of a statistical approach based on random observation to understand how efficiently the labor uses its working hours. However, the work sampling is a time-consuming and based on manual data collection. For that, new efforts have been focused on automating this process using sensors. For that, they are trying to associate selected work categories with new indices. For example, they are looking for work category recognition, looking at worker physiological signals. For example, looking at heart rate, workers' movement, looking at hands and arm movements. So now we are looking for new ways to measure direct work based on other indices that can be easy to recognize and also to table for data collection, like for example, looking for walking and transportation activities. Regarding the research methodology, we adopted exploratory case study as our research method. We conducted the case study in the city of Odense in Denmark. It was a building renovation project consisted of around 20 buildings. Each building presents around 2 to 4 floors, totalizing around 600 housing units. The construction process that we studied, it was the processes made by the carpenter trade, which involved 22 workers. The main activity conducted by those workers were remove and construct new internal walls, ceilings, windows, and balconies. The research design presented 4 stages. data collection preparation, gathering data, collecting feedback from workers, and results analysis. Talking in detail about each stage during the data collection preparation, we conducted a meeting with managers in the job site. During this meeting, we defined the trade observed. It was the carpenter, the period of the visit, weeks 25 and 26 of the last year. And also we selected the smartwatches for collecting the travel distance. In that case, it was the Xiangmin for running 45. Following with the second stage, during the gathering data process, we use the work sampling technique to understand the time spent in 6 work categories, those being preparation, direct work, transportation, walking, talking, and waiting. We use the TallyAccount app that I'm using here in this picture to record observation with a timestamp. Continue in the gathering data stage, we adopt smartwatches to collect workers' travel distance. For that, we developed a protocol to use the smartwatches. The first activity of the protocol consisted on the selection of participants. In this case study, 10 carpenters took part of the study. Then we set up the smartwatches, which consists on insert the features of the workers. Then we proceed with the data acquisition that is related to workers wearing the smartwatches on the job site. We can see in this video the activities conducted by the workers, or mainly where they were, and also the last activity was the data cleaning. In the third stage, we collected feedback from workers. For that, we adopted a questionnaire using the Likert scale from 1 to 5. The questioners were interested to understand if wearing a smartwatch impact on their daily activities or not. The last stage consisted in results analysis for understanding the relationship between the travel distance and time spent on direct work. After downloading all the activities from the smartwatches, we could understand the total travel distance at the end of the day, and also the average of the total travel distance in each interval of 30 minutes. So at the end, we have 16 data points. Each point represents the average of the total travel distance and the time spent in each category in intervals of 30 minutes. Moving to findings, let's see the results of the work sampling technique application. The TallyAccount app allowed to us to have the time stamp of each observation, so we could see the evolution of this time spent on direct works along the day. So at the end, we get that 29% of their time workers spend on production activities. So we can get the points, the data point of each interval of 30 minutes to compare with the distance that they travel in those intervals. Regarding the findings of the smartwatches, we can see in these figures that after 9 days of data collection, we can collect the average travel distance between intervals of 30 minutes. Each column represents each smartwatch. We grouped all this information in a new figure, and we can see the average travel every day. So if we focus in the first interval, we can see the average, it was in that period about 0.4 kilometers. So having in mind the distance that they travel in each interval and the share of time that they spend in each work category, we can correlate those data points for understand the relationship between each travel distance with each category. So we can see that we found an interesting correlation between distance and production, different as we expected. The correlation is a strong correlation. It means that the more they travel, the more productive they are. Finally, we were interested to understand workers' perception of wearing a smartwatch. For that, we conducted the questionnaire, and we can see in the answer that they feel that wearing a smartwatch didn't impact in their ethical values, and also they didn't feel that interfere in their works. One of them also even said that it was fine wearing the watch and I will use in the future. Which are the conclusion of our work? Well, regarding the novelty, We presented an hybrid approach for measuring direct work, which combines a consolidated technique as the work sampling, a new index that was the worker travel distance, and also a new technology using the GNSS from smartwatches. Also, our study presented several limitations, mainly regarding the setup process, because we didn't use the physical features of each individual. We adopted the average of a Danish male. Also, we realized that some workers conduct their activities inside, so the GPS could collect some errors because the indoors activities. Finally, we have several next steps in our mind. We are conducting new case studies in new construction projects, mainly related to renovation projects because they conduct most of the activities from outside. Also, we are looking for new indices, like for example, workers' geographic location. Instead of looking at the distance, now we are looking for GPS coordinates. And now for that, we are looking for new approaches. We are using Python programming to classify the GPS positions into workspaces. And that's all. Thank you for your attention.
Let us take it off with an example, okay?
Thank you so much for your presentation. Are we going on to the next one? Or do we ask questions?
You guys have any questions?
Hello?
Hello.
So thank you. Yeah,
Yeah, there doesn't seem to be any questions here.
Danny. Yeah, so are there any questions, comments, contributions to the paper? Thank you so much. Yeah, you can raise your hand or put it in your comments or contributions in the chat box. None that I see, but I just wanted to find out from you, Søren. I think I can see you are in the session. Your title is talking about understanding the relationship between construction workers' travel distance and time spent on direct work. But you have other information, you have other concepts that we analyze, like walking, waiting, production, talking, preparation, transport. Why the deviation from the focus on production to those other activities? Why didn't you just focus on direct production? And then the other one is, can you just interpret when you say the model?
Hi, I think I'm going to answer the question. Cristina is one of the authors of the paper. Can you hear me?
I think I'm lost there. Okay, I'm back. Yeah, so the one is, that's inference. The more they travel, it looks conflicting that someone travels more and then they are more productive. Thank you, Cristina.
Can I answer?
Yes, please,
Yeah.
you can answer now.
Yes, exactly. As you said, we're interested to understand the relationship not only with direct work, but also with other work categories like transportation. And it was interested in that study that the correlation with direct work and productive, it was a strong positive correlation. But maybe because in that case we found several errors collected from the GPS, but now we collected and we conducted more case studies, and we could see that it's not as useful to look the distance to associate with direct work, and is more interested to associate the workers' positions with other work categories. Like, for example, instead of look at how much they travel at the end of the day, look at how much time they spend on workspaces. So yes, it was the first case study. So it was the first try to understand the relationship, but now we find that new indices will be more interested.
That explains it. Then the second one is the more they travel, the more productive they are. It seems as if it's a little bit conflicting. You travel more and then you produce more. So should we ask our workers to travel more so they are more productive?
Yes, that correlation, it was a strange correlation. We found that it wasn't what we want to see, but it's what I said before. We believe that it was regarding some GPS errors. So maybe that distance that we collected in that case study, it wasn't the real distance that they get, because we can find some of the points were outside of the job site. So it measured more than they travel. So now if we are looking in new case studies where all the activities are collected, are conducted outside, we are not going to have these GPS errors, and we can see that that correlation is different. So now we can see that the distance is exactly the opposite, a strong negative correlation. Last, the more they travel, the less they productive they are. So
Okay.
the reason for now is looking for new case studies that all the activities are outside, for not having GPS errors to measure a ground distance.
Okay, fantastic. That would be great. So thank you so much for your response. Do we have any other questions, contributions, or comments that we want to make on the paper? So you can just unmute and then ask your question or type in the chat box. If none, then we can move on to the next paper. So the next paper is titled Research on the Plain Intelligent Design of Homestays Based on Deep Learning. And this paper is authored by Xiaoni Gao, Xiangmin Guo, and Tiantian Lo from Harbin Institute of Technology, Shenzhen, China. Sorry if I didn't pronounce your names correctly.
Hello everyone, my research topic is research on the plain intelligent design of homestay based on the deep learning. In recent years, the demand for tourism and vacation in China has greatly increased, and travel also has greatly become a way of life. According to the research report on the development of China's online homestay industry in 2019, the number of homestays has grown rapidly, and the users of online homestay bookings are younger as a whole. To sum up, homestays are more popular than other accommodation machines in the process of tourists traveling abroad. The homestay not only increases the income for the local residents, but also provides the tourists with opportunity to get in-depth contact with local culture. Under the homestay style, which not only satisfies tourists' psychology of thinking new and different, but also enriches tourists' experience and makes them more impressive. With the increasing demand for homestays, the current number of homestays is still unable to meet the living needs of tourists, which has also led to a bottleneck in tourism development. And the user group of homestays tend to be younger. Users have high requirements for the comfort of homestay spaces. According to the analysis of users' consumption demands for homestays in 2019, nearly 18% of users hope to improve the living quality of homestays. At present, The development of homestays urgently need to break through the bottleneck period of large design demand. Slow design speed, reduction of design cost, low design quality, high adaptability of design schemes, and monotony. With machines assisting the design process, artificial intelligence, automation, and machine learning are emerging as inevitable opportunities and challenges in nearly every discipline, including architecture. International scholars continue to try to combine deep learning in the field of architecture to do related explorations, and have achieved certain research results in building restoration, building facade generation, and community layout generation. Deep learning can effectively reduce repetitive design thinking and modification, which leads to a lot of wasted time. Deep learning can effectively break industrial barriers, lower design thresholds, and realize zero-distance design for owners. Deep learning can tap the seeking market, reduce labor costs, and solve the design needs of design units that are willing to serve small-scale and low-income groups. To sum up, using deep learning technology, the layout skill can be intelligently and quickly generated for the designer's reference, which brings more convenience to the designer, which is beneficial to improve the design efficiency, reduce the design costs, and optimize the space layout. In the design of the renovated homestay, the difficulty of the design is that people involved need to think and ponder over and over again. Looking at the current renovation of homestays, a considerable number of traditional dwellings have the status quo of flanter duplication, loss of connotation, and spatial confusion, which has evolved into the stereotyped situation. Compared with traditional design machines, GNN has a strong learning ability. Therefore, in the design process, it is not necessary to architecturally define the generation rules and specific algorithms. Through machine learning, research and learning can be carried out automatically, and the rules can be found to give reasonable generation results. Therefore, the use of PX to PX in this study can efficiently reduce the repetitive work content of homestay renovation, design and drawing, improve worker efficiency, reduce labor costs, and reducing level of duplication of labor, and can provide homestay reformers with timely reference plans for renovation. In the future, the design and transformation of homestays will have subversive and strategic significance. The filtered samples with different styles and further converted into samples of the same style for training the PX2PX model. In order to ensure the final effect, the proportion and the labeling mentioned of the samples are processed so that the program can identify our structure requirements. Among them, PX is used to draw the spatial area annotation picture of the architectural plan in order to help the machine to identify and distinguish each species. This experiment adopts a set of colors with special RGB values for labeling. Model training 1 is mainly used to train the building subregional ability of the neural network so that it has the ability to divide the process species. The second model training is mainly used to train the ability to generate details of furniture in different areas of the nature network, so that it has the ability to express details of each partition and convert it into the image expression machines commonly used in the gallery for output. After two models are trained, cascade operations and performed on the two models, so that entire model can be completed at one time, and the flight design journey of the homestays is output. Customize the corresponding scoring standards and compare the machine learning results with the traditional designers' design journeys through scoring and evaluation. Analyze and judge the feasibility of its intelligent and repeat design, and evaluated the pros and cons of its design results. Compared with the traditional design machines, the use of deep learning technology for layout generation has the characteristic of high efficiency, low cost, and the simple popularization to non-professionals. The marginal benefit is extremely low, and it has huge advantages in large-scale promotion and popularization. Of course, the use of deep learning technology also has disadvantages, such as large initial investment and insufficient design factor accuracy. Okay, that's all my presentation. Thanks you all.
Thank you all. Thank you so much for your presentation. It's highly appreciated on the plain intelligent design of homestays based on. And I want to ask, are there any questions for the authors? Do we have any questions, comments, or contributions? You can type it in the chat box. Any questions? You can type it in. Doesn't seem as if there are any questions or comments from participants. Or you can raise your hand and then you'll be unmuted. None. But it's a good presentation anyway, and maybe is the author in the room, and maybe just to explain maybe a little bit more on the intelligent design and then the concept of homestays. Is the author here? Xiaoni, Gao, Xiangmin, Guo, or Tiantian? Are they here? Don't think so. Okay, so let's go to the next presentation then. The next presentation, so I welcome you all to this session, one of the sessions of the challenges and opportunities to the use of data. The next presentation is Building Cost Database for South Africa, Key Data Trends and Implications. So I'll be doing the presentation from my side. The author, Abimbola Windapo. I'm the author and I'm also chairing this session.
Yep, we can see it now.
Okay. Hello, everyone. My name is Abimbola Windapo. I'm a professor Can you hear me?
Yeah, we can hear you now.
Okay. It seems as if it stopped playing.
Yeah,
So
yeah. I have to just start that again from the start. The sound cut off.
it's cut off, yes.
Yep, sorry.
Okay, so the presentation will follow this outline. I will look at the introduction and background, research methodology, results and findings, and then conclusions. As introduction. So the introduction and background will, access to adequate, let me go back, please. So the introduction, we find out there is a lack of access to adequate housing in South Africa. There's a infrastructure and housing deficit in South Africa as well. And then we have also the high building costs, which affects the affordability, and then the population growth, and then unavailability of land as well, impacts on affordability of housing. So the access to adequate housing, the need for accurate projections of future needs of housing, also impacts on the ability of the citizens to access affordable housing. And then there's also this interaction that we have between inadequacy and the different socioeconomic factors affecting the housing in South Africa. So the research methodology used, I made use of historical data, and then it followed a longitudinal cross-sectional survey research design, which includes a desktop study, and then historical information was obtained from institutional and government databases. And we also made use of simple or linear regression in the analysis. So what we found out from this historical database, and you could see the trend lines here on this slide, is that the building costs has been increasing gradually over the 5-year period in which the data was analyzed. So there's been a gradual increase in the building cost. And also, this increase is also, we also see an increase in the population growth, whilst unemployment grew constantly. There's a consistent growth in unemployment. And then the corruption index, there was a flat trend line. It grew gradually between 2015 and 2016, and then we see a little dip between 2016 and 2017. Now, the results and findings, what we find out is that there is a positive growth. There's a positive relationship between the population growth and the building cost. As the population grows, building cost grows, so that is understandable. As unemployment grows, we find that building costs also grows. So not so clear there with the relationship between building costs and unemployment, and then the negative relationship between corruption and the building costs, positive between poverty index and the building costs, the rates of building costs, and then inflation as well. There's a negative relationship. We found a negative relationship between the inflation index and building costs. So in conclusion, we find that macroeconomic factors such as the population growth, unemployment, positively impacts the growth in building costs in South Africa. We have the economic variables having a negative impact on the growth in building costs. And then the growth in population and changes in unemployment and poverty has implications for building construction costs. The more, of course, the pressure on the construction industry due to growth in population due to migration is expected to have a positive impact on the building costs. But the unemployment aspect could be due to the fact that government needs to come in now and provide houses, so there's a lot of inputs from the government, and so this may be responsible. Lots of grants, lots of housing grants, social grants to enable poor people to access housing. We also may be the cause of those impacts on the building construction costs. And in conclusion, what I found was that investors have to plan ahead using more social related indicators, because the social related indicators impacted more on the building costs than all the other indicators. So I want to thank you all for your attention, and if there are any questions. Are there any questions? So if there are no questions or contributions, you can see maybe Dr. J.M. Ugo is typing. Okay, said, how do you, okay, thank you so much for your question, Dr. Ugo. How did you derive the building costs? Is this national figures or typical representations of housing costs? So the building costs, we have a building cost, we have a database called the Building and Economic Research Database. So they collate the building costs nationally, and then they publish it quarterly. So that is their national figures of the different types of buildings nationally, and that's how we got the building costs. So they get it from typical, just as you pointed out, typical construction that is going on. So not only housing, but also from institutional buildings, education, all types of construction that is going on, representative from different locations in the country. I hope that answers your question. Thank you very much. Thank you, sir. So we still have 20 minutes left in this session, but since there are no other presentations, no questions or comments or contributions, I would like to thank all our participants, all our presenters for joining us and for their presentation. And yeah, so the conversation continues. I want to wish you all a successful conference and enjoy the deliberations. Thank you so much.